Hey everybody, this is Larry. This is me going over Leetcode contest bi-weekly 41, Q3, Stone Game 6. So this is a tricky problem, so hit the like button, hit the subscribe and join me in Discord before I forget. But the core part about this is going to be greedy. Kind of. So I think the thing that I read from people solving is that they just sort by the sum. In a greedy way, we take the pile that or the stone that has the highest sum for each. Yeah, we just sort them by the sum of the values and then group them that way. And then people, I don't know, I feel like hand wave a little bit with respect to like, they're like, ooh, this is greedy and this is why. And I don't really think that's a great explanation for learning. I actually made some mistakes during the contest. As you saw, I ended up taking 24 minutes because I did a shortcut in my head that turned out to be wrong. And you could watch me solve it live during the contest. But if I went back to first principles, how do we derive this? Right? How do you convince yourself that, choosing the sum of the stone values is good enough? Well, it is something basically a classic sorting trick, if you will, which is the assignment the exchange argument, which is that basically you have two stones, right? And you're trying to maximize your score and minimize Bob's score. So basically, you have two stones, let's say stone A and stone B, right? So I'm going to shorthand it by saying A or B. Well, you may ask yourself, which one is more valuable, right? So let's say let's just have a compare function that compares A to B to figure out which one is more valuable. Well, in this case, the value of the stone is just equal to Alice's. Maybe I should use. Okay, let's use X and Y because Alice and Bob is confusing the A's and B's. So yeah, so that means that the delta of the scores matter, right? So basically, what it means is that okay, I will pick X. Oops. Pick X if this is just me looking. I prefer okay, also I am Alice, let's just say, though actually this turns out to be symmetric, but I'll pick X if X sub A minus Y sub B is greater than X sub B minus Y sub A, right? And what does that mean, right? In English, rather. I mean, that's a formula, and you're happy about seeing that. But what that means in English is that if I pick the stone A, then the other person will take the stone B, right? So we want to choose this if let me rephrase that. If I choose the stone X, I get the value of A, and the other person will get the value of B, right? And from that, well, do we want to pick X? If we pick X, this is the score that we get for X, right? If we pick X over Y, sorry that I'm explaining this kind of a little bit terribly, but we pick X over Y, we will get the score X, X sub A, and the other person will get the score Y sub B. Right? The score difference is X sub A minus Y sub B, right? And if you pick Y over X, then the score difference is Y sub A minus X sub B, right? So then you have this formula that we talked about before, which is something like this, and we want to see whether they're bigger than each other, right? And, well, if you manipulate the formulas a little bit, then you get something like this. X sub a plus x sub b, we compare that to y sub a plus y sub b, right? And this is just, you know, we add x sub b on both sides, and we add x sub y sub b on both sides, and this is what we end up with, right? Let me make this one bigger. So that's basically the idea behind this algorithm, is that, okay, between, and you can also see, make the similar argument for B now, right? Where, okay, this is if I'm Alice. If I'm Bob, you know, you have the same thing, except for the formula is a little bit different. You know, you have B's here and A's here. And similarly, you're saying, if I'm Bob, I pick X over Y. That means that the score difference is going to be, you know, I get the B X score, X sub B score. Alice gets the Y sub A score. And the reason why we care about the difference is that we only care about the the difference that we get, right? So basically, if I'm Bob, this is also the case. And if you kind of put it together, then you have X sub B minus Y A. And if you do the same math, you also get X sub B plus X sub A, you know, something like this, right? Which coincidentally, if you look at this, is symmetric, is the same. So they both basically have the same function that they're optimizing for, right? So that in a greedy way, Alice will always have these kind of ordering, and Bob as well, actually. And I don't know if that's a coincidence. Maybe if you're better at math, you could prove that, that there's a reason why this is the case. But for me, I just kind of, this is how I thought about it, right? And then now, notice that on this side, for each stone, the value is just the sum of the Alice value plus the sum, the sum of the Alice value plus the Bob value. And you don't even need to compare to anything else. And that's basically the proof of everything else. Or everything else follows, because now we sorted. I have a negative thing here because I wanted to sort by biggest number, so you could actually just remove it and do, you know, reversed, and that's fine because now you're getting bigger numbers in the front. And because they have the same formula, they're gonna both pick in the same way. So now what's remaining is that we calculate one at a time the total value of the score difference, right? So basically, because Alice goes first, if the index is mod 2 is 0, then this is Alice getting the Alice score. Otherwise, Bob gets the score and we subtract it. And the delta is basically Alice delta score. So if Alice has higher score than Bob, then we return 1. And if Alice has less score than Bob, we return -1. Otherwise, we return 0 because they're the same. So that's basically how you would solve this problem. And I know that if you read editorials and tutorials and stuff like that, they just mention stuff about greedy. But I think this is the better way to kind of think about how to solve this problem, because this is the way that you will be able to prove to yourself that is correct and generalize it in the future as well. And actually, if you watch me solve this during the contest, I do a variation of this where I do I wrote a comparison function, and I didn't prove that these two are correct, or I didn't prove that these two were the same initially. So I had to do a little bit more uglier code to get that right. But yeah, that's all I have for this problem. Let me know what you think. And you can watch me solve it during the contest now. That's all right. Hmm. Hmm. That's not Hmm. Wow, this is hard. Let me take a look at this one. I don't even know. Did I mess that up? Whoops. whoops. Huh. And off by 1 because I'm silly. 7. Is this right? I rushed it, but wow, I really have no idea how to do this. Yeah, that doesn't make sense. don't know anymore. Maybe that's right. I left that print statement in the packs. Hey, thanks for watching the explanation. This was a little bit of a tough contest for me. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and I will talk to y'all later. Bye bye.